Hello everyone. Welcome back to the past year question solutions for the 6th term examination problems. As usual, we are picking questions randomly so that we can at least cover all of the major sections that are used in the syllabus for this exam. Okay? In this one we have calculations and logarithm. Alright, so logarithmic questions are rare, but you know, it can always appear when you are the one giving the exam. Alright, so to 9 decimal places log 2 is given and log 3 is given. Since everything is been worked on 10 base, when I start writing the solutions, I will not write the base. Okay, remember, if you are not writing the base and just writing log, it's assumed to be base 10. If you are not writing the base and you write ln, it's logarithm naturalis or the natural log or base e. Okay, so if you write ln, you don't need to write base e. If you write log and you do not mention the base, it's assumed to be log 10 base. Okay, unless you are doing it in the chapter of calculus where sometimes it's taken as base e also. Okay, now log 2 is given, log 3 is given. What do we have to do? We have to calculate log 10 base 5 and 10 base 6. Okay, let's do that. So log 5, this is equal to log 10 by 2, right? So this, using the property of logs, this is log 10 minus log 2. This is basically log 10 is 1, so minus that weird value 0.3010, so this is 0.699. We are calculating it up to 3 decimal places, right? So I don't need to calculate it much farther. 699 is enough. When you are calculating something up to 3 decimal places, make sure you are calculating it up to 4 and then rounding it off. Okay, because if you're calculating up to 3, then you do not know what the next decimal is going to be and you might make an error in rounding off. Alright, so always remember, if someone asks you an answer up till n decimal places, calculate till n plus 1 and then round off. Very simple technique. Then we will do log 6. Log 6, I can take 2 into 3, right? That will be easier. Log 2 into 3, which is log 2 plus log 3. Now I have to add these two weird values. So 0.3010 plus 0.4771, which would give me, okay, I'll do the termination and approximation in one step. This will give me approximately 0.778. Right, because 3 plus 4 7, 0 plus 7 7, 1 plus 7 8, and 0 plus 1 1, so approximately 778. Okay, by taking logs or otherwise, show that 5 into 10 to the power 47 less than 3 to the power 100 less than 6 into 10 to the power 47. This is a very weird problem, you might say, but this will make sense once we start the calculations. Right, so let us take the logs of this. This is the problem that we are attempting, right, to show 5 into 10 to the power 47 less than 3 to the power 100 less than 6 into 10 to the power 47. Alright, so let us check log 5 into 10 to the power 47. This is basically 47 log 10 plus log 5, right? Because if I split it into the power rule and the sum rule, I'll get log 10 to the power 47 plus log 5. Now that is by power rule 47 log 10 plus log 5, which will give us 47 plus 0.699, right? This gives me 47.699. Fine. Calculate log 6 into 10 to the power 47. Very similar way. I get 47 log 10 plus log 6, which is 47 plus 0.778 equal to 47.778. Now we have to calculate the middle one and show that it is less, isn't it? So log 3 to the power 100, this is 100 log 3. I didn't know the value of log 3, so this is 100 into, we will need quite a lot of decimal places, right? Because here I have 3 decimal places, so I'll need 5. 0.47712. So this is 47.712. Clearly, if you compare these, We have our proof. Okay, this was easy. We just calculate the values. We saw that 3 to the power 100 lies between 5 into 10 to the power 47 and 6 into 10 to the power 47 via logarithms. Okay, now what does this mean? This means that 5 into 10 to the power 47, this value obviously starts with 5, and 6 into 10 to the power 47 obviously starts with 6. Right, now 3 is greater than 5 into 10 to the power 47, right? So it is basically 5, then 46 zeros and 1. That is where it starts from. And where does it end? It does not reach 6 and then 47 zeros. It reaches 5 and then 47 nines, because it's less than and not less than equals to. So the first digit will always be 5, right? That is the logic. I hope you've understood. If you do not understand, take a smaller value and check. So, okay, even if you do not want to take a smaller value, I'll just re-explain the concept. 5 into 10 to the power 47, if something is greater than this means their value starts from 5, 46 zeros and 1. Alright? And if it is less than 6 into 10 to the power 47, that means that the value which is sandwiched does not touch 6 and 47 zeros. It is 1 less than it, because these are integers, right? So it will be less than or equals to 5 and then 47 nines, isn't it? So 5 9 9 9 9 9 9 till 47. So if it starts from 5 0 0 0 0 1 and goes on till 5 9 9 9 9, then the first digit is always 5. So that is the logic. This also shows, I can just write it now, hence the first digit has to be 5. Alright, now we are going to use this logic and then find the first digits of these three numbers. Alright, so let us make three subcases. 2 to the power 1000. Right, so if we are dealing with 2 to the power 1000, I will just have to find something n into 10 to the power m less than 2 to the power 1000 less than n plus 1 into 10 to the power m. Right, we have to find it in this format, just as we did in the last problem. Alright, now this will tell us that the first digit of 2 to the power 1000 is n. Okay, so we will just check the value of the sandwich first. Alright, 2 to the power 1000, let us check that. So this is basically log 2 to the power 1000, which will be 1000 log 2. Now this means we'll have to take 6 values, so 0 0.301 029 9. So this will give us approximately 301.030, if I can take that. Alright, now here log 2 to the power 1000, that will give me a value of 301.2996. Right, now how do we reach the value of 301 to be exact? I can take 10 to the power 301, right? Therefore our m will be 301. I hope you understood this. We have to first reach the number and then the decimal part, right? So this one is m should be equal to 301. Alright, now if m is 301, we need to find n just. So we have n into 10 to the power 301 log less than, this value is 301.030, less than log n plus 1 into 10 to the power 301. right? We have calculated the value of m. Now what would here what value would give us something that is just less than 10 to the power 301? Now this will become n log 10 to the power 301, right? So this will become n into 301 less than 301.030 less than n plus 1 into this thing is entirely inside n plus 1 into 301. Now I can clearly see that if I take n to be anything greater than 1, this will not be our solution, right? Because this lies between 301 and 2 into 301, right? If I take n to be 2 here, then it will not get satisfied, right? Because this is into and this is a decimal point. All right, please do not confuse there. I'll put it in second brackets. This is into and this is a decimal point. So n has to be 1. So the first digit here is 1. Okay, I can follow exactly similar techniques for the next one. In the next one I have 2 to the power 10,000, right? They're just increasing 1 0. Fine, no problem. 2 to the power 10,000. I'll just increase one more decimal. So again I will have log, I'm skipping some of the steps this time because you know the procedure. I'll just put the values. So log 2 to the power 10,000 now becomes 10,000 log 2, which is approximately 3010.301, right? Now again I have to keep this number as m, right? So I have my m equal to 3010. Again I would have my equation set up such that n into 3010 is less than 3010.301 less than n plus 1 into 301. This will give me again n equal to 1. Alright, so similar problem, similar solution. Next, 2 to the power 1 more 0. One more? 5 zeros, right? That is the last. Yep, 5 zeros. Again here I have log 2 to the power 100,000 is equal to 100,000 log 2, which is equal to 30102.996. Now here the difficulty starts spiking a bit because this is approximately equal to 30103. Okay, this is almost moving on to the next integer, right? Now if it starts moving on to the next integer, so what will I check? I'll check if it is actually, see, in these two numbers what was happening, I was getting the values in the same range, right? Both of the powers were the same, 10 to the power 301 and between 1 into 10 to the power 301 and between 2 into 10 to the power 301. Here if it starts crossing on to the next decimal, by the definition of logarithms is basically indices, right? To a base 10, a change in decimal means going to the next power. Alright, so since this is very near to 30103, this means my m will be changing here. Okay, so here I will have to check two different m's. Now that will throw a spanner in our works, but we will have to adjust to it. So we will check log. Now okay, when will a number go from 10 to the power m to m plus 1? When I multiply it by 10. So basically I have 9 into 10 to the power m format and it's going into 10 into 10 to the power m format, right? Which means it's going from 9 into 10 to the power m format to 10 to the power m plus 1, because 10 into 10 to the power m is 10 to the power m plus 1. Alright, so what will we check? We will start by checking with log 9 into 10 to the power 30102. This just means log 3 square plus 30102, which means 2 log 3 plus 30102. If I pick up the values, I'll get 3012 102.945. Sorry, 954. So I can clearly see that the number is a bit greater than log 9 into 10 to the power 30102. This means that I can write 9 into 10 to the power 30102 is less than 2 to the power 100,000. It's less than 10 into 10 to the power 30102, right? Following the same logic as above, but here since I am multiplying by 10, I can just write 9 into 30102 less than 2 to the power 100,000 less than 10 to the power 30103. This is the step that they will likely want to check in your final exams, whether you have correctly identified that here we are jumping integers. Okay, now our values of m are different in the final form only when we multiply that n plus 1. Okay, I hope you understood. This was the equation that we were following, right? This is the equation that we followed. Since this was the equation that we followed, our m here is still constant. Our m here is 30102, but our n plus 1 turns out to be 10 instead. If it turns out to be 10 instead, then this equation will become n into 10 to the power m less than whatever is sandwiched, less than 10 to the power m plus 1, because that n plus 1 is 10 and it gets multiplied, the power increases by 1. Okay, so this is the only difference in the operations part of this sum. Otherwise the theory is entirely the same. So what does this imply? This means that therefore n is equal to 9. So first digit are A1, B1, C9, right? These are the things that we have marked 1, 1. Alright, so using logarithms you can actually calculate the first digit of a large number of very high valued numbers. Okay, I did not want to use the word large twice, so I had to think of a synonym for it. Okay, so using the very basic definitions of logarithm, you can do this exercise for quite a large number of values, because the smaller logarithms are easier to be calculated, right? You can calculate log. If you know the primes, you can calculate the composites anyway, and then you just have to look between n and n plus 1. Okay, so if you can write a number in its exponential form, it is not difficult using logarithms to at least get an idea of its first digit. Alright, you can also do this for the second digit if you want, but it will be a bit more calculative, because instead of 10 you would have to take the base 100. Alright, which would mean a further reduction in decimal spaces and a look into the first two digits. Okay, so we will cross that bridge when it comes. If it ever appears in the exam and we are looking into the past year questions again, I'll try to solve it. Alright, anyway, if you do have any questions about this particular video that I completed right now, you can send your queries to this WhatsApp number. Alright, of course you are welcome to provide your suggestions and feedback in the comment section of this video, but many of you are reluctant to do this, so please note down this number. Any queries relating to this examination or any other examination or any other mathematics problem that you might face, do not hesitate to contact us. Our team will get back to you with the solutions. Alright, so I'll end this chain of videos here. I have uploaded quite a lot of different solutions to PYQ problems, past year question problems. I've taken them from different chapters, except the draw the graph type of problems, and I explained it to you why, because you will just be sitting here looking at me drawing a graph, right? It will be much better if you can learn to do that yourself. I've already told you the techniques in various different videos. Okay, you either go it via algebraically or use calculus to find the inflection points and so on. Okay, so all those people who are appearing in these exams, best of luck to you, and if you do have any queries, please let us know using the number that I provided. Okay, bye, take care, I'll see you all in the next one.